All right, class. So we are now going to talk about parallel perpendicular lines. So just to backtrack, which you'll see these soon. If I can find it, that would be nice, right? So, for parallel perpendicular lines, remember, first off, we got to remember slope formula. Rise is your y's, over x is the run. Rise over run, y to x. That's how you find the slope, how it is moving to make that straight line on the coordinate plane. Now, it's going to want us to have it in slope-intercept form, y equals mx plus b. However, they may put it in standard form where it's shuffled around, or they might have it in point-slope form. But we need to change these to look like this form so we can instantly see the slopes. Why is that? Well, when we tie it in with geometry standard, we need to show, by definition of parallel and perpendicular on the coordinate plane, are they going to be one or the other or neither? Well, to be parallel lines, the slopes, your m, is going to be the same. If it is the negative reciprocal, so let's say that we have a slope of 1/2, well, the other slope, so that they are perpendicular, remember this means perpendicular, is the negative reciprocal. Reciprocal means to flip. Negative just means to negate. If this is a positive, this is now a negative. So we have 1/2 and a slope of -2. This says that those two lines are perpendicular. They form to make a right angle. Now, if they were exactly the same, they were both the same slope, then they are going to be parallel. They'll never touch. They're rising and running at the same rate to where they'll never meet. So let's apply this to some problems. So if we look where it talks about number 20 through 28. Okay, you'll be getting this shortly. However, it says, determine if those two sides, A, B, and C, D, these two lines, are they parallel, perpendicular, or neither? We are using the slope formula, y2 minus y1 over x2 minus x1. Remember, label your a's and b's, x1, y1, x2, y2. Plug it in and simplify. Do the same for line CD. CD we'll call x1, y1, x2, y2. Plug it into slope and we simplify. Then we see that both slopes are exactly the same, parallel. If we do the same in 21, notice that they are flipped and change signs. It's the reciprocal and negative. They're perpendicular lines. Now in number 22, remember, same idea, find your slopes, but if it's dividing by 0, you can't divide by 0, so that's an undefined slope. They're both undefined here. That's still technically meaning they both have the same slope, so they're parallel. Okay? 23, it gives you 4 points. They want you to see if JK is parallel to LM. So JK is my first ordered pair to check. LM is my second ordered pair to check. And then I compare their slopes. And I see that they're going to have the same slope. Same slope means, oh, they are in fact parallel. 24, I see the perpendicular sign, so I'm hoping that I see the negative reciprocal, right? The negative reciprocal. Now let's look at, we'll go over 25 and 27. Okay, number 25 and 27. So, 25. It says, determine if the lines are parallel, perpendicular, or neither. But notice it's not in slope-intercept form. And they give us 5x minus 3y equals 21. So I need to get these two into the format of y equals mx plus b. It's like we've been doing with algebra in the beginning of the school year. Get y by itself, isolate a variable. First thing, subtract 6x, bring down my 10y. So I now have negative 6x plus 20. And then I divide everything by 10, so it's balanced, but I also get 10 divided by 10 is 1y. I get y equals. If I simplify negative 6 over 10, well, let's see, we get negative 3/5 x. 20 divided by 10 is 2. So now if I look at this, I quickly see that my slope is negative 3/5. So now I need to compare it to this one to decide, parallel, perpendicular, or neither. So I've got to do the same thing on the other one. Subtract 5x, bring down the negative 3y, equals negative 5x plus 21. Divide everything in front of y, so we just get a 1y. Negative and a negative makes a positive 5/3, x minus 7. So now if I look at these two, I see that I have negative 3/5 and 5/3. Are they the same? No. Did they flip? Yes. But is it the negative reciprocal? They flipped it, reciprocal. Is it negative? Yes, they negated. They changed it from a negative to a positive. So it flipped and changed signs. So therefore, they are perpendicular lines. They are perpendicular to each other. Okay? That is the same idea as number 27, actually. You still shuffle things around till it looks like y equals. So you can spot the slope more easily to decide parallel, perpendicular, or neither. All right? So let's see, what else do we have? I'm looking. Give me a second. All right. Yeah, let's go through a couple. So point slope form. I know we learned that a couple days before we got out of school. Well, kind of out of school. You're at home. I am looking on this page. I'm going to go over just a few of them. Not all of them, but some of them. I'm going to first talk about point slope, apply it to parallel perpendicular lines. And if I remember right, you did not have to do 35. 35 was not for you to do. Pretty sure I had you say skip, or I wrote skip on there. So let us look at number 29 first. So 29 is showing what point slope is to show how we can use point slope with geometry, parallel, perpendicular. So point slope is y minus y1 equals m times x minus x1. So if I'm reading number 29, it says write the equation of a line that passes through point negative 6, 1, and it has a slope of 1/2. They just gave everything to us. They gave us point slope, hence point slope form. Point slope form. So I'm going to label my x1, y1. My m is my slope. That's how I move on the graph. So y minus y1 is 1. My slope is 1/2. I'm just plugging and chugging. X minus a negative makes a positive 6. Now, I still want this to look like y equals mx plus b. So I've got to move things around. So first distribute. I'm going to distribute the 1/2. So 1/2 x. Half of 6 is 3. And then I'm almost there. I almost have y equals, but I have that negative 1 in my way, so I add 1. Combine like terms with where it should go. So y equals 1/2 x plus 4. So given a point and its slope, I used point slope formula. So I can put it in a slope intercept form. So I can quickly when we get to parallel perpendicular lines, you'll see in a moment why it's so much easier to spot that slope in this form. So let's apply that. Number 31 is a good one because you will be given problems on the test. I think it's a couple problems where you need to identify the coordinates and then show me what to do. So for example, number 31. Number 31, they give me the graph. I wish I could zoom in, but because of my phone, all right, they say that the slope is 3. Well, that's because they looked at the dots and they were rising 1, 2, 3, 4, 5, 6, right 2. So if I rise 6 and go right 2, my slope is 3. So I have my slope based on my graph because of rise over run. Okay, I don't like that's going to bug me. Rise over run. So I have my slope. Awesome. Well, now I need the ordered pairs, but I don't need both because it's point slope, not points slope, point slope. So pick a point. You could pick the top one or the bottom one. I'm going to pick, the one on the bottom left. So I see it as -2, -1. That's what I'm going to use. Maybe you chose to use, it is 0, 5. That's the other point. You could use that too. You'll get the same answer. So I have x1, y1. I'm going to plug it into my point slope intercept form. So y1, so this is where it's, be careful, minus a negative makes a positive 1. Slope, we counted on the graph, it's 3. And then x minus a negative makes a positive. Now I distribute. I get 3x plus 6. Almost there, need to subtract 1. So that way I have y equals 3x plus 5. Y is now by itself. Now let's tie this in. It says, yeah, that's right. So this is the slope of the line. Did not have to do this. You're going to laugh and be like, really, Miss Santiago? Then why would we just do that? Well, this is the slope of that line, right? It says write a linear equation that's parallel to the line below. So we want it to be parallel. So if my slope is 3 on this graph, to be parallel, it needs to be the same slope. So I know that I'm going to use the same slope that they gave me. But what point? Well, it says, write a linear equation that's parallel to the line below and passes through the point -4, -13. So we actually only needed this graph to find the slope. Now, I find it as good practice to show you how to get it into slope-intercept form, but all you needed is this part. You had to look at the graph to find the slope, and they gave us the point it should be passing through. So now, x1, y1. So I have y minus a negative makes a positive, equals my slope is 3. X minus a negative makes a positive 4. And now we distribute. So y plus 13 equals 3x plus 12. Remember, you multiply, you don't add them. You don't get plus 7. Subtract 13 on both sides. So it's just y equals 12 minus 13 is -1. So if you look at these two equations, I can see that they are parallel because the slopes have to be the same. But this is my final answer. This is what they were specifically asking, but I want to visually show you the difference. This is what the graph is they gave us. This is the line that will be parallel to that line on the graph. Okay? So, last thing to talk about is go. All right, I know these problems are a little intensive, and I understand, but you have one problem on the test where this is already worked out. You decide what to call it. But there is one problem where you do need to work this out. So yes, there's two problems, but one is worked out for you. You decide what it's called. The other one, you do need to show this work. Okay? But it's open note. You get to look at your study guide and all your notes. So that is a plus in this situation for you. So you have to find the distance between each point, because we need to classify. Is it a parallelogram, a rectangle, a rhombus, or a square? Well, first off, remember your given distance formula. It's like how we found the radius when given the center and a point on a circle. But now we're using it to help us classify quadrilaterals. It has many uses. So you're still using this formula, but I know you're using it once, twice, thrice, and then first and last. 4 times. Quadrilateral is 4. Sorry, my cat's getting in the way. Go on, Oliver. All right. So you find the distance of each one. Well, I see they're all equal. Well, this tells me all sides are equal. So either it's a square or it's a rhombus, which is a slanted square. We've got to decide which. Well, next is, this narrows it down from 4 options to 2. Now I need to look at my diagonals. So we don't know if it's a rhombus or a square, but I'm just going to draw a 4-sided figure. And this is STUV. STUV. So now I have to look at the diagonals. Because if the diagonals are congruent, then it is a square. If the diagonals we find are different values, it's a rhombus. So I see visually I need to find SU. I need to find the distance from S to U. They got square root of 233. They need to find the distance from T to V. And they find it to also be square root of 232. Since they are the same, we narrowed it to 2. Their diagonals are congruent. This is a square. If they were not congruent, it's a rhombus. If I look at the next one, same idea. Distance formula 4 times. And notice I see 2 sides are square root of 82. Whoops, 82. And 2 sides are square root of 20. Well, this tells me that, okay, it's either a parallelogram or a rectangle. They're not equal. It's not a rhombus or a square. So that narrows it down for me. But then you've got to find the diagonals. So I'm just going to draw. We don't know what it is yet. We'll figure it out. E, F, G, H. So we've got to find diagonal EG. They found it. And it's apparently square root of 58. And FH. They use the distance formula. So I see the diagonals are different. If the diagonals are not the same, it's a parallelogram. If the diagonals were the same, let's say they were both square root of 58, then it's a rectangle. Okay? So if the diagonals are congruent, it's either a square or a rectangle. If the diagonals are different, then it's a rhombus or a parallelogram. But we first have to see, well, if all sides are congruent, rhombus or square. Are they not all congruent, but there's 2 of the same, parallelogram or rectangle? Then check your diagonals. This will tell you your final answer. Okay? All right. So, any other questions? Please contact me. I have Google Duo. I sent y'all a reminder of how to contact me, Google Duo. I did activate Google Classrooms. It seems like a lot of y'all like that, but I also invited you all to it as well. I will give you updates on the school's website where my name is at for digital learning, as well as on Google Classrooms. And of course, for those who are on Remind, I will send you a remind as well. All right, we'll keep in touch.